Hello everyone, myself Senthil, working as Assistant Director 2 in National Water Academy Pune. This National Water Academy is under the Central Water Commission, New Delhi. Here I explained about the overview of rainwater harvesting briefly. Why this topic necessary now is we have so many water crisis problem in India. So every Indian have aware about this rainwater harvesting technique. This rainwater harvesting techniques already sufficient awareness created by Government of India or school level and state level also. Here just I will explain the overview of rainwater harvesting and the water sectors. Before starting, I explain the Tirukkural narrated by Thiruvalluvar. நீரின்றி அமையாத உலகினின் யாரார்க்கும் வானின்றி அமையாத ஒழுக்கு. What is the meaning is, if water fails, nature is completely ceased. If rain fails, no human can walk straight forward. That is, no one can do their duty in an ordered way. So, in ancient day itself, Thiruvalluvar said about importance of rainwater. So, nowadays we can think about this point. This is typical hydrological cycle. Already we learned in school level also. I just explain the briefly. So, here in ocean or sea, normally the rainwater goes to sky. In the sky, due to condensation process in clouds, again it's come down to earth through precipitation. Here the precipitation is nothing but rainfall, snowfall or sleets, etc. So whatever the water forms come from the sky to the earth is, we can call it as precipitation in simple manner. Once precipitation reach the ground, some of the water infiltrates to the earth surface, so we can call that as infiltration. After that, some of the water taken by trees, forest species, and some of the water can utilized by humankinds. So after this, the river flow through again to sea. So again this cycle is taken place continuously. So here the trees or plants, the evaporation take place. It's called transpiration, which is means also called evapotranspiration. So evaporation goes to sky, again it's come to precipitation again goes to sea in the form of a river, flow back to sea. This is the continuous cycle process. If any problem taken place or break in this chain, we can affect enormously. So in this point I will wind up these slides. I will go to next slide. Here I explained the world water scenario. See, you take our earth is surrounded by 97% of salt water. Only 3% we have the fresh water. In the fresh water, out of 3% of fresh water, in 87% is in the form of ice. So the 87% of water we cannot utilizable. So in that 12% is groundwater and 1% is rivers or lake. So 12 plus 1, 13% water is we can utilize presently. So this much we can get overall idea about water and all over the world, especially fresh water we have. So here 97% is water is not usable already. Only 3% water only we can fresh water. In the 3%, 87% is gone to ice. So we can get only very meager quantity. So now we can get small awareness. Water is very precious thing. We must conserve it. Before going to further slides, I will explain some mathematical terms which can be very useful to imagine whatever units I will tell in further slides. Let us take 1 meter, 1 meter, 1 meter box, that is 1 meter length, 1 meter breadth, 1 meter height. In that we can fill 1000 liters of water. So 1 meter cube means 1000 liters of water. Imagine 1 billion meter cube means this much, that is 10 to the power of 9 cubic meter is equal to 1 billion meter cube. In further slides I will explain in water in the quantity of billion meter cube, that is BCM. So in why I am telling this, if I explain in BCM, you can imagine how much water it means in 1 BCM. So that's why I explained in these slides. Okay, so here total precipitation received in India is 4000 billion cube billion C BCM, that is we can shortly call it BCM. In total precipitation, the total availability is 1869 BCM only. In that 1869 BCM, we can utilizable water resources only 1123 BCM. In the 1123 BCM, we can get surface water of 690 BCM and groundwater of 433 BCM. So surface water current utilization, that is present utilization, is 65% only. Here 56% only, that is groundwater. So more or less 65, 56, more or less almost the same. We can utilization is groundwater is 56 and surface water is 65%. So in this surface water and groundwater, we can use majority of water in irrigation sector only, under domestic purpose, that is drinking, bathing, etc., for human utilization, usable kind of things. And industrial usage more or less same, that is nearly 6 to 7% of water goes to domestic and industrial, and nearly more than 70% of water goes to irrigation purpose only. Imagine, so our irrigation sector or agricultural sector, we must save the water and divert this water to our domestic purpose also. So we can save this for mankind drinking purpose and etc. So we can take good initiation to implement recent technology like drip irrigation and Israel technology, whatever. So you can save this water and save this water to divert to domestic sector. So this is a typical model for rainfall we already seen. So here also I explained it. Here one point I explain new things I will explain here. Here the rainfall falls from the sky and it's flow through the river and finally reach the ocean. Before that I already told some water go to infiltration and moves to groundwater and moves as groundwater. This groundwater is held by an aquifer. The aquifer is a new term I included in these slides. I will explain further what is an aquifer. Okay, here the rain is a liquid water in the form of droplets that can condense from the atmospheric water vapor and then become heavy enough to fall under gravity. So next slide. Okay, water demand. As per international norms, countries with a per capita water availability is less than 1700 meter cube per year is categorized as water stressed country. So what is per capita demand is water demand per person per day into 365 days is called per capita demand per year. That is, if some of the country or any country which have total calculate the total quantity of water divided by that population of that country, we can get the per capita demand of that country. So India have only 1545 meter cube water per capita. So definitely our India is a water stressed country. Here see the typical bar chart. Here we can projected the demand in future, that is 2025 to 2050. Definitely in 2050 we have water stress enormously. We can see here only 1140 meter cube of water is there, but at that time the population is very big, so the per capita demand is very less. As per international standard, 1700 is below 1000, maximum 1700 meter cube is necessary, but we can reach 1140 meter cube only. So we can aware about this water stress condition in India. Here I tell you about this overall view of rainfall. In India, the 75% of annual rainfall is received in the June to September month, that is monsoon season. We can generally technically called as monsoon season. The average annual rainfall in India is 119 centimeter. I will explain how to measure the rainfall in centimeter, millimeter, and how can imagine our common people how can imagine. So I will explain in further slides. Here two features in Indian rainfall, that is in North India the rainfall decreases westwards, and in peninsular India it decreases in eastwards and then increases in coastal region. I will explain this point in further slides. As per Indian Meteorological Department, there are 4 climatological seasons, that is winter, summer, monsoon, post-monsoon. The summer season also called the pre-monsoon, that is December to February. The 12 months is divided by 4. So December to February, March to May, and June to September. Post-monsoon is autumn season, October to November. Our India receives June to September only 75% rainfall. So this is very good given of rainfall. Here see the map. I already explained. In India, the rainfall is decreases towards, in North India decreases towards westward. In South India it is decreases towards east side. In coastal region, see very dark. So in coastal region the rainfall is very good. It is excess, very good amount. So this is I explained in that previous slides. So this slide shows the annual normal rainfall. What is annual normal rainfall? The rainfall normal has been computed using rainfall record out of 50 years of network of nearly 2412 stations all over India. This data is received around in the year of 2000. So in those periods, Indian Meteorological Department installed 2412 stations. So in the 2412 station we calculated the rainfall and computed 50 years period. So based on this we came to know that in this red color or orange color region we have severe deficiency of rainfall, and the green colors are show a good amount of rainfall. Here see the majority of Indian regions shows very good amount of rainfall only. So from this point we can conclude that the rainfall or nature given the ample or good precipitation to our country. So is human duty or Indians or our duty to conserve this rainfall. The rainfall is good amount, so we cannot neglect this point. So we can store this rainfall for future usage. Here this diagram shows the the rain gauge stations installed, the station installed by Indian Meteorological Division. There are nearly 3,700 rain gauge stations installed in India. So previously I showed 2004-112 only, that is those period only a less amount. Presently we can have 3,700 rain gauge stations as per IMD records. Here I taken the rainfall data of the January to December month, January to December 2018. Here we see the red color shows the deficient rainfall states and the green color shows the average normal rainfall rates only. This is Kerala region, the excess rainfall. So from this point, majority of states have good rainfall only. So from this point, rainfall is good. Our duty to store it properly. That is our duty. So this is one of the typical diagram how to measure the precipitation. I will show one by one. Here you can take one box or container 1 meter by 1 meter length and breadth, and height is whatever 60 centimeter or 50 centimeter whatever. Here the rainfall we can record it for 1 hour. For 1 hour, how much water collected, how much quantity of water collected in the container is the point to taken for consideration of rainfall. For example, in this slide 10 mm water is taken for consideration. For example, if you get 10 mm water in 1 meter by 1 meter container, we can conclude a total quantity of water is 10 liters. So from this point we can say that 10 liters of water is occupied in 1 square meter area. This is how we can imagine the rainfall if this tell in mm or centimeter. This is 1 centimeter. The 1 centimeter rainfall, we can get 10 liters of water in 1 meter square area. So same I will expand here. It is assumed that surrounding field has also received an uniform water depth of 10 mm. We can rainfall of 10 mm. We can get 10 mm depth of rainfall in 1 square meter area. This is the concept we can kept in our mind for imagination purpose. If some TV channels or newspaper telling the rainfall is centimeter or mm, so we can imagine whatever they're telling in this quantity, we can imagine that quantity into occupied in 1 square meter area in 1 hour. This is the sum of the rain gauge stations, rain gauge instruments. There are so many rain gauges, basically recording type, non-recording type. Here I show some of the typical rain gauge for your point of view or imagination. This is aquifer. So already explained regarding aquifer. Now aquifer is nothing but groundwater is the water that seeps through rocks and soil and is stored below the ground. The rocks in which groundwater is stored are called aquifers. Aquifers are typically made up of gravel, sands and limestones. The aquifer can yield water, and also we can extract water from the aquifer. So there are so many terms are there: aquifer, aqueduct, like that. So here I not explained about these terms, not necessary. Here our point of view only aquifer is necessary, so I can explain here. This is one of the Indian map, geological map regarding aquifer in India. There are so many aquifers in India. Based on the colors, the geological information may vary. For example, these data are received from the Central Groundwater Board. This is the principal aquifer system of India. So every colors show the type of aquifer. What is the type of soil or aquifer, whatever. So next slide I explain the what is the contribution of this aquifer regarding groundwater. For example, here I see this is the Gangetic Plains, that is northern India. The soil is alluvial soil. So alluvial soil have the good yielding capacity. We can store enormous water. And come to southern state in South India, especially in Andhra, Karnataka, Tamil Nadu, the geological features show the quartz soil. The quartz have very meager yielding capacity. So the water scarcity is more here. So groundwater cannot yield from this soil. So here this point we can understand. The groundwater is not only based on the this one human fault, based on our natural fault also, based on the geological condition, that aquifer condition. The water can store, or we can conserve it technically based on the aquifer condition also. So whatever water resources project we can construct or implemented in states or all over India, we can consider this geological point of view also. Then only we can get 100% results from these water conservation or whatever water sector projects. So here this slide show whatever the color I showed, no, this Gangetic Plains, that is a pale yellow color. Here see the pale yellow color, the yielding capacity is 10 to 6500 meter cube per day. This is alluvium soil, and so many soils are there. I will explain the quartz soil only in southern state. Only 2 to 400 meter cube yielding capacity per day. So based on these principal aquifers in India, we can understand the yielding capacity of various states. So this is have the good yielding capacity, and come to down decreasing, and based on this genesis, whatever this, based on instructives low yielding capacity. So based on this only we can understand the aquifer system in India. The next slide I explained the water scarcity in worldwide. Here see I explained world map. There are 4 scarcities he mentioned here: physical water scarcity, economic water scarcity, and no water scarcity, and no estimated here. Here in India, majority is showed as marked as red color. So we can understand India is physically water scarcity country. And you see the orange color, what is economic water scarcity? The economic water scarcity is nothing but those country did not investment in water resource projects. They, even though they have the enormous water in their country, the proper management is not there. There is no investment in water sector. That is called economic water scarcity. So due to this, the water exploitation is happened in those countries, which leads to water scarcity, economic water scarcity. This slide shows the gap between the surplus and existing supply and projected demand in 2030. Here see the majority of Indian countries shows the blue color. The blue color shows the severe gap between the supply and demand. This map is based on the river basin: Indus River, Brahmaputra River, Meghalaya, Meghna River, Kaveri. So this is west flowing river, this is east flowing river, this is Pennar Basin, Narmada Basin, Tapti Basin, so Godavari. So the Godavari is moderate, this one moderate demand. Here the blue color show the severe demand. So the green color shows the demand is a surplus. There is no, that means there is no demand. So surplus water is there, available is there. This scenario is based on the 2020 demand, projected to 2030 demand. This typical Indian map shows that 54% of India faces high to extremely high water stress country. See the majority of states show the red color. The red color shows the high stressed country, high stressed states. This is arrived from the World Resource Institute. Groundwater in India. Around 45% of total irrigation and 80% of domestic water come from groundwater reserves only. India has abundant groundwater reserves which gets replenished every year mostly by monsoon precipitation. I already told them due to monsoon we get 75% of rainfall. During that period, our groundwater is replenished by every year by precipitation. See the nature, every year whatever they taken from our ground or air, again they repeatedly given to our earth. So this is hydrological cycle is must happen to keep the ecological balance. If if we exploit the groundwater or unutilize the groundwater, unwantedly utilize the groundwater, we can face severe water demand in future. However, in some states, for example, see Delhi, Punjab, Haryana, and Uttar Pradesh, the exploitation of groundwater has led to water scarcity. These, even though these countries have the Gangetic Ganga river, they will exploit the groundwater. Like other arid regions, that is Rajasthan and Gujarat, very arid climate leads to water stressed condition. But in Tamil Nadu, Karnataka, Andhra, the poor aquifer, I already told Tamil Nadu, Andhra, Karnataka region have the poor aquifer condition due to quartz aquifer. So there is water scarcity is more here. With increasing population pressures and industrial growth and unprecedented pace of urbanization, the groundwater is extracted from lower and lower level with a much faster rate than rainfall can even replenish. This is serious issue. This is the typical diagram of rainwater harvesting. I will explain further detailedly. What is rainwater harvesting? The rainwater harvesting is nothing but it is a means to understand the value of rain and to make optimum use of rainwater at place where it falls. That is the simple meaning. Here what we do presently like this only. We cannot conserve the rainwater. Just we can expect water from other resources. The rainwater is the primary resource, and other waters from lakes, pond, river, etc. are the secondary resources. First of all, we can save the primary resource. That is the very important thing. So already told, rainwater is the primary resource. From rainwater we can get lakes, river, ponds, groundwater, etc. This is the secondary resource. In present times, in absence of rainwater harvesting and conservation, we depend entirely on these secondary resources only. If we cannot save the rainfall, we can only depend on only the secondary resources. And it is the process to forgotten that rain is the ultimate source of that feeds these secondary resources. So we can understand rainfall is very, very important. According to study conducted by Central Water Commission, the annual requirement of 3000 billion cubic meter of water can be managed from annual rainfall of 4000 billion cubic meter if rainwater is harvested properly. I already told we have the water resource of 4000 million cubic meter. Out of 4000 billion BCM, we can store nearly 3000 billion meter cube of water from rainwater harvesting technique itself, as per Central Water Commission. See, that's a very important point. But we can harvest only 8% of the rainwater, which is the lowest in the world. I will tell you some of the benefits of the rainwater harvesting. First one, they provide relatively high quality water, soft and low in minerals at low cost. Direct capturing of rainwater significantly reduces our resilience or water from dams, reservoirs and canal systems. This will exert less pressure on national water storage capacity at macro level and can potentially reduce the need to expand dams or build new ones. Capturing rainwater likelihood of overloading stormwater system is in neighborhood. Reduces soil erosion and flooding typically created by stormwater runoff in urban areas of India. Encourage households and institutions to be equipped with on-site and decentralized water supply of reliable quality. Reduces silting and contamination of waterways from polluted surface runoff and helps to create mass awareness and appreciation of conservation of water resource. And etc. So many benefits are there. I will point out only 7 in the slides. Here see the typical bar chart, the various stages of rainwater harvesting. This is very simple. First of all, we can collect the rainwater from the channelizing through proper channel and then filter it and storage it. There are 2 types of storage. One is storage from our level and utilized for our daily usage, and another one is groundwater recharge. We can do duties. One is storage and groundwater recharge. The groundwater recharge is also very important things to replenish the groundwater. Another this typical bar chart show that in India and world rainwater normal. The average rainfall in the world all over world is around nearly 800 mm, but India have 1200 mm, which is more than the world rainfall data. So this much rainfall we have in India. So it is the every Indian citizen's duty to conserve it properly. Countries like Israel, Slovakia uses water 4 to 5 times before it disposing of. If before disposing of the water, wastewater, they utilize the recycling the water 4 to 5 times before utilizing. But in India, only one time usage, only use and throw. We can dispose it unmanner, improper way. So this certainly not very encouraging situation in India. So this leads to scarcity in India. Techniques of rainwater harvesting. There are so many techniques. I will tell the 1 or 2 simple things which we can follow in our home. See this diagram. I show the rainwater from rooftop rainwater harvesting. The rooftop harvesting for direct use and groundwater recharge also. Here we can collect the rainwater from the rooftop and collect it in one tank, whatever syntax tank, cement tank, whatever, RCC tank, whatever, we can collect it. And simultaneously, parallelly, we can recharge the ground level or aquifer. So if can do like this, we can avoid flooding as well as ground level sinking also. So this application of this technique can contribute major helpful to avoid these situations. This water is stored for dry season, the reserve for dry season. This diagram also more or less same to previous slides. Here show the roof. From the roof, the rain, the gutter, the rain is collected for storage tank, and some of the waters goes to the recharge the ground. This is one of the important slides. I will explain one by one. 80% of India's drinking water needs dependent on groundwater only. So the drinking water 80% is dependent on groundwater only. Out of this, 2/3 of water for irrigation supplied by groundwater. 2/3 of water is supplied to groundwater only. 84% of total addition to irrigation over the last 4 decades has come from groundwater. 60% of India's districts face groundwater over exploitation. See, we wasted 60% of groundwater. This is very bad situation. Here, due to depletion of groundwater, we can have subsistency. In Kolkata, the estimated average land subsistency is 13.55 mm per year. The subsistence is nothing but sinking of the land. If groundwater, 1 mm drop of groundwater, the sinking of ground is increasing. This leads to flooding, so many natural hazards. Here 60.70 percentage of well in India with water below 10 years average. You see the 17.5% of these below the average of 2 mm or more. States covered in the Central Groundwater Board survey. See the Tamil Nadu 80.6% of total tanks, that is wells, here less than or equal to 2 mm below the average, that is the 10% average depth, 10% average 10 years average, the water depth is very decreasing. This was a very critical scenario of groundwater scenario in India. Due to exploitation of water, we not only face water scarcity, also the GTP loss also in India. So this is the right time to save the water, especially in rainwater. Friends, I will take one small example how to calculate rainwater, how much quantity we can save in rainwater based on roof harvesting technology. For example, here I will take Pune city. The Pune city, the average annual rainfall is mentioned as 781.9 mm. So this data is arrived from Indian Meteorological Department for 25 years average. So from based on this average data, finally we get this data. Okay, I will explain how to calculate the how much quantity rainwater we can save. This is one of the small calculation. Rainwater harvesting potential, that is rainwater harvesting potential is equal to rainfall in mm into collection efficiency. For example, I already told Pune city have received nearly 780 mm of rainfall. So you have house with a roof catchment area 100 square meter area. The height of the rainfall, for example, you take 0.6 meter. So volume is defaultly we can multiply depth, height here, that is area of plot, that is 100 square meter. Height of the rainfall already you know 780 mm. So you can get 78,000 liters of water, volume of water you can collect that from your rooftop. So these 78 liters we cannot get fully. We can some efficiency to calculate. Some of water evaporated, some of water flushed. So effectively harvested water quantity is these 78,000 liter into coefficient of evaporation. Some of the water can evaporate now, so we can include this coefficient to tackle the evaporation. And surface runoff, some water loses in surface runoff also, so we can take surface runoff. Here I take tile finish. My roof is tile finish, so I will take tile finish coefficient. So as per Indian standard norms, normal condition of domestic consumption, the water in India, the per capita water in India is 135 liters per day. That is, one human can require 135 liters per day of water for daily utilization. Here we see this 78 into 0.8, that is coefficient of evaporation, 0.85 surface runoff. We can save nearly 53,000 liters of water. 53,000 liters of water we can save for 100 square meter area in Pune city. So small example, for 5-member family per day drinking water is 10 liters average nearly. One man can drink 10 liter waters normally. So for 10 liters into 5 members, we can 50 liters of water per day we require. For 365 days into 50 liters, only we can consume 18,250 liters. That is, we required only around 20,000 liters water only per year for 5 members of family. But based on this, we can store how much? 53,000 liters water. So it is nearly 3 times more. See how much water we can save for our future. So all must definitely or should take this technique and install this technique in every house based on the aquifer, scientific, geological condition, etc. Recharge the groundwater or simply collect the rainwater in a syntax tank and store it and use it for your future. So I explained previously the coefficient of various surfaces. Here based on this and CPWD manual, I will bifurcate this coefficient tiles. I taken this one 0.8 to 0.9. I will take tiles. So whatever our roof, the surface area, ground surface level, roof catchment level, we can calculate accordingly. We can take these data. This is the same one only. So I explained already rainfall in mm. You take a rainfall whatever. This is without calculation. We can, based on this chart, we can easily conclude at how much rainfall we can save normally. For example, the rainfall is, you can take 800 mm or 600 mm, 100 meters roof square, 100 meters roof area, 600 mm, 48,000 liter, 48,000 cubic meter of rainfall you can save. That is 48,000 liter rainfall you can save. So based on this data you can calculate how much rainfall you can save it. So the storage tank of rainwater harvesting tank is so many types: is RCC, masonry, ferro cement, PVC, etc. Whatever you can use it. This is one of the recharge hand pump rainwater harvesting. Here the typical the roof water is come to recharge the ground also, and at the same time you can get water chamber, you can store it and whatever. So I already told the recharge structure should be taken up with unpolluted surface water only, and also they should not be taken up with shallow water table areas. So some areas have water table is high level. In those areas we need not to install rainwater the recharging techniques in those areas, because already the area is enormously with waterlogged areas. So avoid those areas, and the depth of the water level should not be less than 5 to 6 meters in post monsoon period. This is a criteria to consider while designing the recharge structures. The recharge structure should be preferred for recharging depleted aquifers with deep water table. The structure should not be taken up in impervious clayey soil, rocks and steep sloped areas, and also catch the rainwater from the localized catchment surface such as roof or house, plain and sloping grounds, surface, etc. It is easy to collect rainwater and divert into the ponds, vessels or underground tanks to store for longer period and to recharge by construction of rainwater harvesting structures in suitable sites. It should be planned taken up with overexploited and critical areas experiencing incentive groundwater development for various uses. This is a typical diagram. This is the roof area, that is catchment area. This is the conveyance girder. We can provide pre-treatment process, that is filtration process. After filtration we can collect simply rainwater here. This rainwater also used for irrigation, distribution, whatever we can use it. There are so many rainwater harvesting techniques and enormous engineering knowledge is implemented in this. Here I explained only roof, for this simple we can easily implement it in our house. So I will explain this method only. It's the same one only, this also. This is the open area conservation. He can plot the one area and collect the for 3-4 houses jointly conserve the rainfall in open area, and we can collect the rainwater. This is the recharge of rainwater through ground. So many things, gravel, sand, pebbles, we can place it in proper manner in compacted position. We can do it. This is also a typical same diagram only. Based on the guidelines, the gravel, sand, charcoal, we can filter the rainwater. This is for filtration purposes. We can filter and we get pure water. This is one of the typical sponge type filtering techniques. This also same method only. Underground storage tank, filter. This is filtering unit. Rainwater collector from the roof. It goes to filtering unit, and this is storage tank. This is used for garden purpose also, and we can utilize it for bathroom, tabs, latrines, etc. In these slides, I explained the overview of tanks in India as per third minor irrigation census conducted on 2021. Here, total tanks in India nearly 5.56 lakhs. Out of these, only tank in use is only very less, and nearly 4 lakhs tanks only in use. Tank not in use, that is nearly around 1 lakh tanks is not in use. So you can use these 1 lakh non-use tanks. You can rejuvenate, restore it, and use it. We can store enormous water. This is the area for 5.56 lakhs tanks irrigated. This much area for tanks with 1 lakh tanks not in use, that is damaged tanks, we can rejuvenate and we can utilize it for this much million hectares, that is nearly 1 million hectares. So this scheme is called repair, restoration and renovation. So triple R, normally called a triple R project. As per Ministry of Water Resource or the Department of Ministry of Water Resource, Pradhan Mantri Krishi Sinchay Yojana, that is PMKS, was launched in 2015-16 with the aim to enhance the physical access of water on farm and the expanded cultivable area under assured irrigation, improve on farmland use efficiency, sustainable water conservation practice, that is Har Khet Ko Pani, is one of the component of PMKSY. The scheme of triple R of water bodies has also become the part of the PMKSY. Under this project, the cabinet approved nearly 9,050 crores for PMKS component, which target to create 21 lakhs hectare of irrigation potential, including 1.5 lakhs hectare from triple R of water body schemes. Here see, the scheme is to rejuvenate these, restore these water tanks and increase the irrigation capacity, that is irrigation potential, increase the irrigation potential, 1.5 lakhs hectares. This is the funding pattern of the triple R scheme. For example, 7 northeastern states including Sikkim and 3 hilly states like Himachal Pradesh, Jammu and Kashmir, Uttarakhand, the funding pattern is 90% funding is given by central government and 10% from state government, and other states 60% fund is given by central government, 40% by state government. In general category states, 25% by central and 75% by state government sharing the amount for triple R projects. This is a typical diagram for how to implement the project. This is first of all, we can identify the water bodies in UNIQ code, preparation of DPRs by field level implementation agencies like government agencies, Panchayat. First we can identify the water bodies which is not in use. So after that they will given the details to district planning committee. So these after this district planning committee, it's come to district level implementation agency. This district level implementation agency given to the proposal to state level nodal agency. The state level nodal agency given to conducting TAC meeting and approve the proposal. After that, it goes to state level sanctioning committee and the field offices of CWC. Finally go to field office of CWC. Then field office of CWC scrutinizing, monitoring and appraise it. It's go to Ministry of Water Resource, and finally they will sanction the amount of whatever. Main objective of triple scheme is comprehensive improvement and restoration of water bodies, groundwater recharge, increase the availability of drinking water, improvement in agriculture, horticultural productivity, improvement of catchment areas of tank commands, community participation and self-supporting systems for sustainable management for every water bodies, development of course tourism and cultural activities, etc. So the water management is not only in recent techniques. In ancient days we can studied the water management system. Our pioneer, our grandmother, grandfather of grandfather implemented so many engineering techniques which is very highly technology compared to very highly technologically very better than this century. For example, the harvesting of irrigation, water management systems, we can learn about Chanakya's Arthashastra also using water harvesting system, and also we can get some details from Chola king. Already we know Karigala Chola built their grand Anikut Kallanai dam in river Kaveri river to divert the water for irrigation, and so many water conservation techniques traditionally followed for ancient days. Here some of the examples I quoted for ancient water conservation techniques or recharging techniques or tanks. This is the Jalras are typically rectangular shaped step well. It is located in Jodhpur to conserve the water. These steps will collect the subterranean seepage of upstream reservoir of lakes. Jalras are built to ensure easy and regular supply of water for religious rites, royal ceremonies and community use. This is Bandi, normally called a Bandi, or reservoirs that store water for household consumption and drinking purpose. It is located in Udaipur. This is Bawaris, which is located in Rajasthan. This is also one of the typical water harvesting techniques implemented in ancient days. This is Tanka. These water conservation techniques, rainwater harvesting techniques used in Rajasthan region. Here the rooftop, that is rooftop harvesting, is implemented in those days. Country yards artificially prepared catchment flows. Once completely filled, the water stored in tankas or lost throughout the dry seasons and is sufficient for family 5 to 6 members. This Panamkeni is located in Wayanad, Kerala region. They store some of the tribal people store the water for their families. This is called as Eri tank. This is called as Eri in Tamil Nadu. It is old water management systems in India, still widely used in states. It is used to control flood control system and prevent soil erosion and control the wastage of runoff during the heavy rainfall periods. This is the Ramtek dam located in Maharashtra region, also used to conserve water, and in dry season you can take water from this tank. This is the Bayoli, and these step wells are located in Rajasthan, Gujarat region, looking very beautiful also. See, our ancient people give how much importance to conserve the water, how they implement the structures like this. We can very wondering about this. So from the ancient techniques we can follow modern technique also. We can preserve ancient whatever tank they constructed, and also we can follow modern technique to conserve rainwater harvesting. So Water is the blood of our earth. Save it for future generation. Jai Hind. வரமாட்டா இருப்பாரு சோய் வச்சான்னு தெரியல